Okay, we're going to be doing LeetCode 203, which is called remove linked list elements. So this is a linked list question where you have to remove values from the linked list. So the way we do this is we need a pointer. We need a dummy pointer or a sentinel pointer to create the new list, right? In any case, let's read this. So if you find a node whose val equals this target val, which we want to remove, in this case, here it was 6, we remove it. But how we're going to remove it is we're going to have a pointer previously here that skips it. Like we set that previous pointer's next pointer to this, right? So essentially we need a previous pointer, right? The changes happen with the previous pointer. We have a current pointer at the current node that we want to remove, still connected with the rest of the list, but then our previous pointer connects this previous portion to this. All right, so let me show you what that looks like, the actual algorithm. Let me show it to you on the diagram. So let's say our target is 1, right? We want to remove all nodes whose value is 1, right? Then we're going to do this. We're going to have a previous pointer, right? That's pointing here, right? And we set its next to, this, right? And then the current node, which is here, the current pointer, which is at this position, right? We move it to this position. So our current moves from here to this position. So we're essentially just forgetting about this connection, right? This connection still remains. We're not taking time to delete it. This connection still remains, but we're just moving it like that. And then again, we check here, there's no problem, we leave it, right? And then when we check here, if there's no pointer that we want to delete, we still move our current pointer to this next position. And then we check here like, oh, we need to remove this. How do we remove it? We should have moved our previous pointer to, we should have moved our previous pointer previously to the current position. Let me just erase it, made a small mistake there. Should have moved this as well. And then current is here. We want to remove it. Then we use previous to move this whole thing to that position, right? This still is connected, right? Hold on a second. I think I have to redraw it. So our current node is still connected to this, right? But then our previous is now at this position, right? So then we move our current forward, and then we check, is there a 1 in this node? No, there's none. So we move our previous to where current is, and then we move our current to none, right? But this previous here was a dummy node. The previous here was a dummy node, so we need to provide the dummy node.next so that we can return this. So let's write that in code and then we'll redraw it. All right, we'll write it in code, and then because this is actually a tricky question. 1 2, 1, 3. And our target is 1. That's what we want to remove, right? So let's write it in code. Well, we need a dummy node to keep track of the previous and create a new list, right? So dummy, we're going to initialize it with -1, and then we need a previous, then we need to connect the dummy node to the head node. So dummy is equal to head, and then we connect, we create a previous that will create the new list. So previous will equal to dummy. And then we need a node 2 to traverse the head list. And this will be cur is equal to head. So now we iterate through the head list using cur until it's at none. Because remember, every node, every list will, the last element on every list will be pointing to none. So while cur, this means the same as cur, does not equal to none, we check if the value at the node cur is equal to our unwanted value. So if cur.val is equal to val, and by val we mean this val. They should have called it something else like target. Then, as we showed in the algorithm, we use the previous pointer to discard current node. How do we do that? Previous.next is equal to cur.next. So let me show you what we've written so far, right? So our target is 1, and this is the array that we're trying to. This is the array that we're trying to remove the nodes that are 1, right? So here we initialize the dummy node. So let's initialize it in the drawing. We're going to call it dummy, right? And we initialized it to -1. Then it was pointing to none, but then we pointed it to, we set it to head, right? And then we create a previous that will create the new list, right? So we have a previous node, which we're going to put here. And then we have a current node, which is going to be here. That's what this code does, right? So now we iterate through the head list using the current node. So while current is not none, we check if the value is equal to or the unwanted value. So here we can see that where our current is the same as our target. So how do we skip this? We're going to move this. Hold on a second. We're going to move this over here. All right. So in that case, this is still pointing to this, right? When we do this, is still pointing to that. But let's continue writing our code and you see. So next up, else, if the number was fine, we simply set our previous to current. So this is how we move our previous forward, right? And we'll see that code work. But for this case, we had found a node that we wanted to remove. After either removing or pushing our previous forward, we set our current to current.next. Right? So now we're coming to this because we executed this code. So there was no need to execute this, right? So now we're at current.next. So we are moving this current to this position, right? And this connection will still be there, but we're just going to forget about it. Hold on, we're just going to forget about this connection, right? So then we come back all the way up here. Current still has a value in the diagram, you can see. So if current equals to a value, if the node at current is a value that we don't want, which is 1, but we don't execute this, that means current has a value we want, so we simply push our previous forward. So our previous is now controlling the same node, and then after that we push our current forward. Right? Then we come back. Current is still a value we want. No, I mean it's still packed. So if current.val contains a value we don't want, which is 1, right? As you can see here, this node has 1, which we don't want. Then we eliminate it by moving our previous. By moving our previous, let's do this, right? Our previous still has a connection to this, but we're discarding it. So essentially this is how our code looks, right? And then, so since we've executed this code, right, we move our current forward. Right, so our current moves forward to here. I'm going to just move this a bit back here. Right. So we moved our current, we come back here, our current still has a value. So we drop down to if current.val contains a value that we don't want. Nope, it contains 3. So we push our previous forward. After pushing our previous forward, we push our current forward. So now our current is pointing to none, or null in other languages. So we come back here, current is none. So what do we do next? We want to return the, if you look in the diagram, we want to return this, not the dummy, right? So we return dummy.next, right? So we want to return the head and not dummy. So we return dummy.next. So you notice that, yes, we are removing the values. We're removing these nodes, but they still have a connection to these, right? We're just creating like a pathway. Even the dummy still has a connection to this, right? So that is the solution, right? So let's run it. Oh, we made a mistake somewhere. Okay, I made a mistake somewhere. While current, hold on a second. Okay, I made a mistake somewhere in the code. I don't know where it is. I'm trying to figure it out. Dummy is equal, oh, it was dummy.next, sorry. Yeah. So that was it, my bad. Voila, it works. And this is an O(n) time with O(n) space solution. And that's the solution to this problem. So thank you, and yeah, this is the solution. So see you next time.